All right, so let's talk about inverse functions. So here I've graphed a function for you. Let's call this function f, and I've labeled some points. So we're going to find the inverse of f, the inverse function of f. Okay, and it's a really, really simple concept. So all you do to find the inverse function is just switch the x and the y on every point on the graph of the function. Okay, so every point that's on the graph of f, we're just going to switch the x and y values and plot those points, and that'll be the inverse function. So let's do that. So the point 5, 4 is on f, so we know that the point 4, 5 has to be on the inverse function. 1, 2, 3, 4, and 5. Okay, so there's the point 4, 5 on the inverse function. Now here's the point 3, 3. So if you switch that x and y, you stay with 3, 3, and that point is on the inverse function. Right. You have the point 2, 0 on f. So on f inverse, you would have the point 0, 2. It's here. It's 0, 2. Okay, on f, you've got 0, negative 3. So on the inverse function, you would have negative 3, 0. Should be here. You have the point 4, 4 on f. So on f inverse, you would still have the point 4, 4. Right, so let's see now if we can graph this function. We know some points on it. So let's imagine, so this goes from, so the original function went from 3, 3 to 5, 4. So this function would go from 3, 3 to 4, 5. So it's going to look like this, and it'll keep on going forever just like that. All right, the original function went from 2, 0 to 3, 3. So this one will go from 0, 2, 3, 3. It'll look like that. And the original went from 0, negative 3 to 2, 0. So this will go from negative 3, 0 to 0, 2. So it'll look like this. I almost missed that dot. Here we go from 4, 4 to 0, 3. So we'll go from 4, 4 to that. It'll look like this. And then it'll keep on going forever. Okay, so we have a graph of f inverse now. And the symbol for that will be f with a little negative 1 above it, like that. So this exponent negative 1 is just a symbol that means f inverse, or the inverse function of f. All right, something really important to notice now about this graph. Let's say that I graph the line y equals x. Okay, so y equals x, you would have a point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4. And there should be negative signs on those. Lost my mind. Negative 4, negative 4. And negative 5, negative 5. I'm going to draw a dotted line because this line is not really here. It's not part of the graph. It's just something to help us. Okay, so this is the line y equals x. All right, so can you see the relationship between f, or the graph of f, the graph of f inverse, and the line y equals x? So what happened to this black graph to get the blue graph? Well, we reflected it across the line y equals x. So if you take the black graph, flip it over the y equals x, the green line, you'll get the blue line. So see, this portion has just been reflected across. This portion just got reflected across, reflected across, reflected, reflected. So to graph if you have the graph of f and you want to graph its inverse, you can just draw the line y equals x, reflect across that line, and you'll have the f inverse function. All right, so here I've graphed this relation f, and I've also put in the line y equals x there for reference. So a couple questions about this graph of f. is f a function? So remember, to tell if something's a function, you use the vertical line test. So does the black graph pass the vertical line test? So everywhere where I draw a vertical line, does my vertical line only touch one time? So I can pass it through here, it touches once, touches once everywhere, never touches more than once. So this is a function. Passes the vertical line test. All right, is f 1 to 1? Okay, remember that 1 to 1 involves the horizontal line test. So does the graph of f pass the horizontal line test? Well, no, it fails the horizontal line test. I can draw a horizontal line here. That will touch my graph twice. Right? If I put this horizontal line in, it touches more than once. So it fails the horizontal line test, so it's not 1 to 1. All right, let's graph the inverse function. Okay, so I didn't label any points exactly, but we can still draw the inverse function. So what do we know? First of all, this point is on the line y equals x. So this point is 0, 0. That's the origin. So this point has to be on the inverse function as well. This point is on the line y equals x. We don't know what it is. It might be like 7, 7. But whatever it is, the same point would also be on the inverse. All right, now all we have to do is reflect across this line y equals x. So if I reflect this across the green dotted line, I'll get something that looks like that. If I reflect this across the line y equals x, let's see, this will be this area, something like that. And this will look like that. All right, good. All right, so now some questions about the blue graph. All right, first question, is the blue graph a function? So does it pass the vertical line test? Well, no, it doesn't. If I draw a vertical line here, it'll touch more than once. So it's not a function. It fails the vertical line test. So no. Okay, so it's not a function. What caused it to not be a function? Where did it get messed up at? Well, notice the original graph was not 1 to 1 here. So it failed the horizontal line test. When I reflected it across the line y equals x, the fact that it failed the horizontal line test here now causes it to fail the vertical line test. So since the original function was not 1 to 1, the inverse function, or the inverse relation, is not going to be a function at all. What about f inverse is at 1 to 1? Does it pass the horizontal line test? So anywhere I draw a horizontal line, I never touch more than once on the blue graph. So yes, it is 1 to 1. So now you can obviously see the relationship between a function 1 to 1 and the inverse relations. All right, let's write an equation for the inverse relation. So I have the function f of x equals 3x plus 7. I want to write the equation for the inverse function here. All right, so this is really simple. So remember, an inverse relation just means you switch the x and the y. So here's my y, here's my x. I'm going to switch those. I'm going to make my y be my x, and my x be my y. Right. So f of x is just a y. So I pretend there's a y here. I switch the x and the y. This becomes an x. This becomes a y. And then I'm going to solve it for y. So I'll subtract 7 from both sides. I'll divide both sides by 3. And I've got an equation for the inverse relation. I'm just going to fix it up, and I'm going to write it in the terminology we're using. So f inverse of x would equal x minus 7 over 3. So this is the terminology for the inverse function, f raised to the negative 1 of x. All right, let's find an inverse relation for this function. All right, so again, I'll switch the x and the y. Here's my y, so that'll become x. So x equals 7 times y plus 3 squared minus 5. And I want to solve that for y. So I will add 5 to both sides. X plus 5 equals 7 times y plus 3 squared. Now I'm going to divide both sides by 7. So x plus 5 over 7 is equal to y plus 3 squared. So I isolated the expression that's being squared. Now I'm going to take the square root of both sides. So we have y plus 3 equals, remember you get two solutions, plus or minus the square root of x plus 5 over 7. And then one last step, y equals negative 3, so I subtract 3 from both sides, plus or minus the square root of x plus 5 over 7. All right, notice that if I plug in some number for x, work all this out, I'll get two solutions, right? I got two solutions right here. So if you plug in a number for x and your equation spits out two answers, then you know it's not a function. So this is not a function. Okay. I get two answers, so it's not a function. And you can think about that because the original was a parabola. This original function was a parabola. Its vertex was at negative 3, negative 5. Negative 3, negative 5 right here. And it opened up. So it was a parabola that looked like that. Notice it's not one-to-one. So when you do the inverse of that, you get something that's not a function. This fails the horizontal line test, so when you reflect it across a line y equals x, it'll fail the vertical line test. So the inverse is not a function. All right, so we won't use this function terminology, we'll just leave that as y. So here's the inverse relation, that it's not a function in this case. Over here, this is a function. If I plug in a number for x, I only get one answer out of that. The original was just a line. So it was one-to-one, so when you flip it or reflect it, so it passed the horizontal line test, so when you reflect it, it'll pass the vertical line test. So this is a function. All right, so let's think about something interesting here. So take this function, and let's find f of 2. So if I plug 2 in here, 3 times 2 is 6. 6 plus 7 is 13. So I plug in a 2 and I get a 13. So that means on the graph of this, you have the point 2, 13. All right, so what does that mean about f inverse? What point do you know is on f inverse? 2, 13 is on f, then 13, 2 better be on f inverse. Let's see if it is. So we should be able to plug 13 into this function. So f inverse of 13, it better give us 2. Let's see if it does. So if I put 13 in here, 13 minus 7 is 6. 6 divided by 3 is 2. So just like we expected. Now let's try one more of those just for fun. Let's plug, say a 5. So let's do f of 5. Okay, what's f of 5? 3 times 5 is 15. 15 plus 7 is 22. So I know that the point 5, 22 is on the graph of f. So that means the point 22, 5 is on f inverse. Let's see if it really is. So f inverse of 22, it better be 5. Let's see if it is. 22 minus 7 is 15. 15 divided by 3 really is 5. All right, so let's look at what we just did in this terminology. So let's do F circle F inverse of 4. So remember that that means F of F inverse of 4. So this means plug 4 into F inverse first. Okay, so 4 minus 7 is -3. -3 divided by 3 is -1. So that becomes F of -1. So if I plug -1 then into F, 3 times -1 is -3. -3 plus 7 is 4. Okay, so we started with a 4. We fed it into the inverse function. It spit out a -1. Plug the -1 in F, and we got back to 4 again. Right, and if you think about that, that's exactly what you would expect to happen based on what we just did a minute ago. All right, let's do it the other way around. So F inverse, circle F of 1. So that means F inverse of F of 1. So this time I'm going to plug 1 into F first. 3 times 1 is 3. 3 plus 7 is 10. So I want F inverse of 10. So plug 10 in here. 10 minus 7 is 3. 3 divided by 3 is 1. And again, you got right back where you started. You started with a 1. You ended up with a 1. All right, let's do that more generally now. So instead of a specific number, let's do F circle F inverse of X. Okay, so this will be a lot of fun. All right, so this means F of F inverse of X. F inverse of X is X minus 7 over 3. So I'm doing F of this whole expression. So that means we plug this whole expression, this whole function, into the original function. So all of this has to go right there where the X is. So I would have 3 times X minus 7 over 3 plus 7. So I took all of this and I'll put it right there where the X is. All right, my 3's cancel, and I'm left with X minus 7 plus 7. And now my 7's cancel, and I'm left with X. That's exactly what you should expect to happen. If you started with an X, fed it through both of those, you should end up with an X, just like we did with a 4 a minute ago. All right, one last example. Let's do this the other way around. Let's do F inverse, circle F of X. Okay, so again, by definition, this means F, that's an ugly equal sign, F inverse of F of X. So that means F inverse of the whole expression F of X. So that's 3x plus 7. So this time, I'm going to plug 3x plus 7 in here to this expression. F inverse of 3x plus 7 needs to plug 3x plus 7 into the inverse function. So all of this goes right there. So that would be 3x plus 7. 3x plus 7 here, minus 7 all over 3. My 7's cancel, and I'm left with 3x over 3. My 3's cancel, and I'm left with x just like you expected.